Hi, Software Engineering Lecture 6. This presentation will explain the important step of how to create a simplified use case diagram. It is a crucial part of making software successful. I will break down it to make it easier to understand what is a use case diagram, use case components, include versus extent, and some examples. Adopted from Software Engineering, a practitioner approach, 7th edition slides, and Rogers Pressman's Software Engineering, 9th edition. Use case. Introduction to the use case. Fundamental concept in software engineering. Use cases serve as a foundational concept in software engineering, offering a structured approach to capturing functional requirements. Importance of understanding use case. They provide a means to illustrate how users interact with the system, essential for effective software development and requirement analysis. What are use cases? Description of use cases. Use cases depict interaction between user and a system, outlining specific goal to be achieved. They fulfill the design of system from an end-user perspective, enabling effective communication of system behavior in user-centric terms. Purpose and benefit of use cases. Use case exclusively represent the functional requirement of a system, with other aspects such as business rules and implementation constraint addressed separately using complementary UML diagram. Use case in UML, representation in UML framework. Within the unified modeling language framework, use case diagrams offer a visual representation of user system interaction to achieve predefined objectives. Significance of use case diagram. These diagrams effectively communicate how users engage with the system, facilitating clear communication among stakeholders. Purpose of use case diagram. Use case diagram serve several important purposes in the early stage of development. Specific the system context. Use case diagram define the scope and boundaries of a system by illustrating its interaction with external entities such as user and other systems. For example, in an online banking, external entities like customers, ATM machines, and the banking network are depicted in the diagram showcasing how many interact with core banking systems. Capture system requirements. They provide a visual representation of how users, you can say actors, interact with the system to achieve specific goals. Capturing the functional requirement of the system. For example, a use case diagram for a library management system would include actors such as librarian, borrowers, and administrators, along with their interaction like borrowing books, returning books, and managing library resources. Validate system architecture. Use case diagram help validate and refine the system architecture by identifying key functionalities and their relationships, facilitating better design decisions. For example, in a ride-sharing app, use case diagrams help identify core functionality like booking a ride, tracking drivers' location, and handling payment transaction, ensuring the system architecture supports these requirements. Drive implementation and test case generation. By detailing user system interaction, use case diagram guide the implementation process of translating requirement into functional components. They also inform the generation of test case to valuable systems behaviors. For example, for an e-commerce platform, use case diagram outline user actions like browsing products, adding item to the cart, and checking out, which are then translated into software feature during implementation. Collaborative developments. Use case diagrams are typically developed collaborative by analysis and domain experts. This collaboration ensures that the diagram accurately represents the system's requirement and objectives. leading to a more effective development process. For example, analytics and domain experts work together to create use case diagram for a healthcare management system, incorporating input from doctors, patients, and administrative staff to capture diverse user interactions and system functionalities. These are the components I will discuss in next few slides. Actor guidelines. Unique actor name. Each actor in the diagram should have a unique name. If multiple actors share the same name, they are combined into a one actor to simplify the diagram. For example, in a hospital management system, there may be multiple actors named doctor. These actors can be logically combined into one doctor actor representing all doctor interacting with the systems. Unique symbols for actor. Actor must be represented by a distinct symbol in the diagram to avoid confusion. Association with the use cases. Every actor must be associated with at least one use case in a diagram. An actor standing alone without any association is not useful. For example, in an online shopping system, the customer actor should be associated with the use case such as browse products, add to cart, and checkout to illustrate their interaction with the system. Limitation on associations. An actor can have only one association with the use case. They cannot be connected to the same use case multiple times. Example, in a banking system, the customer actor should have a single association with the withdraw funds use case. Having multiple association for the same use case would lead to redundancy and confusion. Generalization relationship. Actor may be linked through a generalization relationship indicating inheritance or specialization among actors. Example, for actor, teacher actor may inherit attributes and behavior from a more general employee actor. Actor responsibilities and expectation. Actors have specific responsibility toward the system such as providing inputs and expectation from the system such as receiving output of feedback. Examples in a social media platform, the user actor may have the responsibility to post content and the expectation to receive notification about new messages or update. Multiple role of actors. Actor can play various roles with the system. Example, in a university system, a professor actor can play the role of an instructor, researchers, or advisor, depending on the context. These flexibilities allow actors to fulfill different roles with distinct systems. By following these guidelines and understanding the role and relationship of actors in a use case diagram, stakeholders can effectively model the interaction and behavior of the system. How to identify actors? User of the system. Identify individuals or entities that directly interact with the system to perform tasks or assess its functionalities. For example, in a banking system, user may include customer, tellers, and managers. Installer of the systems. Determine who is responsible for installing and setting up the system initially. For example, IT administrator or technician may be the installer of the software application. Starters of the system. Identify user or process. Initiate the system operation. Example, user logging onto online platform or automated process triggering system setup. Maintenance of the system. Identify individuals or team responsibility for ongoing maintenance, updates, and support of the system. For example, IT staff, uh, developers, or system administrators. Shutdown indicator. Determine who or what initiate the shutdown or termination of the system. For example, user logging out of an application, schedule maintenance task, or automated shutdown procedure. Other system interactions. Consider interaction with the external systems or subsystems that communicate with the current systems. integrate with the payment gateway, external database, or third-party API. Information recipients identify parties or systems that receive information generated or processed by the system. For example, reporting tools, analytic platforms, or external stakeholders. Information provider determines sources or systems that provide input or data to the system. Um, Examples: data feeds from sensors, user input forms, or data important from external source. Automated process identify any automated processes or schedule events that interact with the system. For example, batch processing jobs, system backups, or schedule data experts. By addressing these questions, stakeholders can effectively identify the actors involved in the system and ensure comprehensive coverage of user interaction, system dependency, and external integration. This facilitates accurate requirement illustration and system design. Rules for use case in a use case diagram. Every use case must have a unique name in the diagram to maintain clarity and prevent confusion. If multiple use cases share the same name, they are logically combined into one. For example, in hospital management system, if these are multiple use case named admit patient, they are merged into one to avoid redundancy. A use case must be represented by an ellipse, the symbol designation for use case in a diagram. This ensures uniformity and ease of identification. Use case must be connected to at least one actor or at least one use case. To avoid isolation, if connected to an actor, it must through an association. If connected to another use case, the connection must be include or extend relationship. For example, in an e-commerce system, the use case make payment should be connected to the customer actor and the process order use case to deposit its interactions. A use case have at most one relationship with another use case. Preventing redundancy and maintaining clarity, multiple relationships between two cases are not permitted. Example, in a banking system, the transfer funds use case should have only one include relationship with the authorized transfer use case to avoid confusion. These rules ensure consistency and coherence in representing use case within a use case diagram, facilitating effective communication and understanding among stakeholders. Identifying use cases by systematically exploring these aspects and considering each actor's perspective, you ensure coherence and consistency in identifying use cases that accurately reflect the user stakeholders needs and requirements. This approach fosters effective requirement elicitation and system design, aligning the system's functionality with user expectations. Actor's desire function, being any understanding the specific function or task that each actor desires from the system to accomplish their objectives. Example, in a banking system, customer may seek to check account balance, transfer funds, or request statements. Information storage and management identify the types of information stored in the system and the actor. Responsibility for managing this data thorough creation, retrieval, updating, or deletion. For example, administrator may create user accounts, customer may update personal information, and manager may generate financial reports. Notification requirements determine whether the system need to notify actors about changes in its internal state or specific events to keep them informed. For example, user may have received emails notification for password reset, accounts activity alerts, or upcoming system maintenance. Handling external events, identify any external event or input that prompt system actions, and the actor responsible for providing information or triggering these events. For example, our weather forecasting system may receive updates from external sensor with meteorologists contributing input on weather patterns. Use case diagram tips. Organize from actors' perspectives. Structures and organize the use case diagram based on the interaction and goals of the actors involved in the system. For example, for instance, in a library system, actors like librarian, member, administrator would initiate and participate in various use cases such as check out books, renew memberships, and manage inventory. Start simple and high level. Begin with the simple and high level representation of use case, gradually refining and detailing them as needed. In an e-commerce platform, initial use case might include browse product, add to cart, and checkout, providing a broad overview of a system's functionality before delving into specifics like payment processing and order management. Focus on what, not how. Keep the focus of use case diagram as depicting the what of system functionality rather than how. In a social media application, use case like create post, send message, and edit profile highlights user interaction without detailing the technical implementation, ensuring clarity and flexibility in a system design. By adhering to these tips and incorporating relevant examples, stakeholders can effectively leverage use case diagram to capture, communicate, and understand the essential functionality of a software product. Use case level of details. Use case generally refer to the level of details as to which information is organized within use case specification. It plays a crucial role in facilitating effective communication between stakeholders and developers, as well as enhancing product planning. Cloud level. This highest level of abstraction representing enterprise-wide goal with only a few overreaching use cases. Provide a strategic overview of organizational objectivity and primary business functions. For example, use case includes advertising goods, selling to customer, managing inventory, overseeing the supply chain, and optimizing transportation. Flying kite level, a step below the cloud level, focusing on business unit or departmental goals, offering a summarized perspective. For example, provide a high-level overview of key business processes within the specific units or department. Use case encompasses student registration, making travel reservation, air hotel, car cruise, and managing departmental budget. What are C-level? Represented over centric goals are activities that can be completed within a short time frame, typically 2 to 20 minutes. Highlight user interaction and essential business activities that drive day-to-day operations. For example, use case includes uh, registering a continuing education student, adding a new customer to the database, placing item in a shopping cart, and completing an active checkout process. Fish level provides detailed functions or sub-functional use cases, offering a general view of system behavior and interactions. Focus on a specific task or functionalities within larger business progress, catering to one more specialized requirements. For example, use case involves selecting a class, paying academic fee, looking up airport codes, and generating customer list based on such criteria. Seabed calm sea level, the most detailed level focusing on some functional aspects with the intricate technical specification and requirements. addresses specific system functionality or features, often at a low-level implementation details. For example, use case entail secure login, authentication process, dynamic HTML field addition, and web page updates using Ajax technology. Uh, Finally, each level offers a progressively detailed view of system functionality, creating to different stakeholders' need and perspective. Use case generality should align with the project scope, complexity, and requirement, ensuring effective communication and understanding across all involved parties. Rules for generalization relationship. A definition of a generalization relationship. The generalization relationship can be used between a pair of actors and between a pair of use cases. For example, in a university system, a student actor may have a generalization relationship with the more specified undergraduate student actors. Limitation on generalization relationship. There are most one generalization relationship between a given pair of actors or a given pair of use case. However, one actor may have a generalization relationship with any number of actors or for use cases. For example, a person actor may have a generalization relationship with both students and faculty actors in a university system. Independence requirement. If used between use cases, the two use cases connected by the generalization relationship must not have any other relationship between them. In other words, they are independent of each other. The generalization relationship only help the designer in coding. Example, in a banking system, the use cases withdraw funds and deposit funds may have a generalization relationship indicating they are share common functionality but do not directly interact with each other. Labeling conventions. The generalization relationship does not have a label. Rules for associations. Existence of association. An association with an exists only between an actor and a use case. For example, in a banking system, the customer actor may be associated with withdraw funds use case to depict the interaction between the customer and the system. Labeling conventions. An association does not have a label. Limitation on association between a given actor and a use case. There can be at most one association. For example, in an online shopping system, the customer actor should have a single association with the place order use case to avoid redundancy. Representation of cardinality. And an association may have a cardinality which can be included on either end of the association. It is represented by one of the following formats: a single integer, a range of integers, or symbol indicating 0 or more. These rules ensure coherence and consistency in representing association within a use case diagram, facilitating effective communications and understanding among stakeholders. Rules for include relationships. Existence of include relationships. And include relationship can exist only between use cases. For example, in a document editing software, the save document use case may include check document format use case to ensure proper formatting before saving. Representation of include relationship. Every include relationship is represented by a straight line connection and must also have the label include. Direction of include relationship. In a use case, uh, include another use case B then the include relationship arrow point from A to B. For example, in an online shopping, the place order use case may include the calculate total use case, where the calculation is performed before placing the order. Limitation on other relationship. If a use case A include a use case B, then there cannot be any other relationship between A and B. For example, in a reservation system, if the book flight use case includes the check seat availability use case, there should not be any additional relationship between them. Transitive of include relationship: if a use case includes a use case B and if B includes another use case C, these rules then technically include C. However, the connection between A and C is not shown in the diagram. These rules ensure coherency and consistency in representing include relationship within a use case diagram, facilitating effective communication and understanding among stakeholders. Rules for extend relationship: existence of extend relationship. An extend relationship can exist only between the use case. For example, in a reservation system, the upgrade seat use case may extend the book flight use case to handle cases where customer requests seat upgrade after booking. Representation of extend relationships: every extend relationship is represented by a straight line connection and must also have the label extend. Directions of extend relationship: if a use case B extend another use case A, then the extend relationship arrow points from B to A. Notice that the arrow is reversed between include and extend. Example: in a software for documents processing, the insert image use case may extend the edit document use case to provide additional functionality of inserting images. Limitation are other relationship: if a use case B extend to use case A, then there cannot be any other relationship between A and B. For example, in a banking system, if the authorized transaction use case extends the withdraw fund use case, there should not be any additional relationship between them. Transitivity of extend relationship: if a use case C extend to use case B, and if B extend another use case A, then technically C extend A. However, the connection between A and C is not in the diagram. These rules ensure coherence and consistency in representing extended relationship within a use case diagram, facilitating effective communication and understanding among stakeholders. Include versus extend key differences. Understanding nature of relationship. Extend represent optional and specialized behavior, while include signify mandatory and shared functionality. Use case independency: extend allows for the independent existence of both, and these extending use cases include incorporate shared behavior into the including use case. Flexibility versus reusability: extend offer the flexibility to add optional features, while exclude promotes reusability of consolidating common behavior. Consideration: extend for optional variation or enhancement to a base use case. Use include for common behavior shared among multiple use cases. So understanding the difference between extend and include relationship is essential for accurately modeling use case diagram and ensuring effective communication of system functionality and behavior. Writing a use case. Use case number. Assigning a unique number to each one use case helps maintain organization and allows for every easy reference during development and testing phases. Use case names, description, and goals. Providing clear and concise names, description, and goal for each use case aids in understanding the purpose of scope and functionality represent. This prevents ambiguity and help prevent scope creep throughout the development process. Actors represent entities, either human or system, that interact with the system being developed. Identifying actors clarifies who or what initiates and participates in the use case, such as buyers, credit card companies, or shipping companies in an e-commerce scenarios. Primary actors are the key stakeholders whose goals are directly fulfilled by the system. While they may not always initiate the use case, they often play a significant role in its execution and outcomes. Stakeholders are individuals or group with vested in intersects in the functionality and success of the system. They may not directly interact with the system but benefit from its operation. Identifying stakeholders ensure their needs and expectations are considered during development. Preconditions define the states or conditions that must exist before the use case can be executed. Triggers are events or conditions that initiate the execution of use case. Post condition have described the expected outcome or states of the system after successful completion of the use case. Basic flow. The basic flow represents the optimal path through the use case where all steps execute successfully without encountering any errors or exceptions. Sorry. Alternative paths represent deviation from the basic flow, typically due to error, exceptions, or unexpected events. Developing use case. The purpose of use case diagram in UML is to demonstrate the different ways that a user might interact with the system. Developing a use case involves a written description of how user will perform tasks on your system. It outlines from user point of view our system's behavior and it represents a request. So safe home exact example. If go through with it, stop the clip and read it thoroughly, and you can understand okay, how can we make a develop use case. Benefit of use cases. Clear communication. Use case provides a clear and concise way to communicate requirements between stakeholders. For example, presenting use case in a project meeting helps stakeholders understand expected system behavior effectively. Visualization. They help stakeholder visualize system interaction and understand user needs. For example, diagram representing the use case flows aid in comprehending the sequence of steps involved. Requirement analysis. Use case aid in identifying and prioritizing functional requirements. So for example, examining steps within a use case help find out specific functionality needed to support user interactions. Validation. Use case serves as a basis for validating system functionality against user expectations. For example, during user acceptance testing, stakeholders reference use case to ensure the system behave as intended. Best practice for creating use case. Keep it simple. Use concise language and avoid unnecessary details. Focus on goals. Describe what user want to accomplish rather than technical implementation details. Be iterative, refine and update user use case throughout the development process as requirement evolve. Involve stakeholders. Collaborative with stakeholder to ensure use case accurately reflect user needs. Use case are invaluable tools in software engineering for capturing and communicating functional requirement. By understanding and creating use case effectively, software terms can build systems that meet user expectation and deliver values. Uh, this is example, use case example registration. You just stop the clip and you can go through with this, and it has alternative flows, post conditions, main flows, and all. They have a step by step. And then another example, online shopping, and they have a similar headings, main flow, actor flows, and preconditions. Online shopping system, you can see the actors, and then the other side, one you say there is a one actor, and on the other sides you see administrator identifying providers, credit payments, and PayPal. So they have a login issue, okay, and then the customer is items, make purchase and customer checkouts, and then is the credit card payments are the things are provided. Here again ATM transaction, uh, simple, you can see online help is extended, which we already discussed, and there are three actors: customer, manager, bank managers, and then the database. And include example, we can see the withdraw, deposit, and transfer fund is related to the, all are related to the card identification. Obviously, if the card identification is there, then they can uh, buy the things or draw the money from their accounts. Here are some more examples. You can see there is a restaurant management, customer, waiter is there, and chef and manager. They all belong to different roles, and the customer can view, order, place orders. The waiter is take order and then serve the food. Cook, chef, all of just preparing the food, and the manager is meeting inventory and managing the stock. Acha. Uh, right, Ji. And second one is smart home automation use case diagram. There is obviously the person who is working on automation systems and the homeowner, and homeowner obviously monitor, control, managing energy and control lighting. The third one is library management system, librarian and borrower. Obviously, if you go to the library, you can see them, and they all are having login or librarian, and then they buy the managed books, and then they keep the record of their books, order the book, update book, and all the record. Whereas the borrower is have their own system, view the books, search books, and come this. So basically, the librarian has a more function as compared to others. Thanks for watching. If you enjoy the content, consider subscribing, hitting the like buttons, having a comments, and sharing it with others. Thank you.